Well, great. It's great. It's wonderful for me to be here. I guess I travelled 30 hours to go through Europe and then finally end up in Dublin. It's a fantastic city to be. What I'm going to be talking about today is accessible augmented reality. But just so I get to know my audience a little bit, how many of you have heard of augmented reality before? Wow. How many of you have built an augmented reality system? Okay, well, by the end of the talk tonight, in 18 minutes, you'll each learn how you can build your own AR interface in a matter of a few minutes, and I'll give you a live demonstration of that as well. So those of you who are in the audience who want to build an augmented reality system, you can go home tonight and you can build your own system before you go to bed. So, last year during the American presidential elections, we saw some examples of that, and so here's an example from CNN where this guy had the billboard card. He turned it over and suddenly this 3D image of a pie chart appeared superimposed on his card there. And a more practical example perhaps is from a medical application where you can look inside the patient's ankle and you can see a 3D volumetric visualization of the bone, and it makes it appear like it's inside the ankle. So this is in March 2007, the MIT Tech Review picked it as one of the 10 most exciting technologies of the year. If you do a Google Trends on augmented reality, something happened around January this year, and suddenly the relative search for augmented reality quadrupled, and so we've got 4 times as many people looking at augmented reality since then. I'll tell you why that happened in a minute. And then Gartner has their hype cycle where they track technologies through the technology trigger phase, through this trough of digital illusionment, and finally the peak of productivity. And you can see augmented reality is right here. So we've got this trough in here. So my passion in life, I guess, is to try and get it from here over to here as quick as possible so that we can all benefit. And that's where you come in. So hopefully you can help me with that. In Star Wars, they had this great scene in the first movie where Darth Vader is phoning one of his starship captains, and the starship captain appears as this 3D hologram standing beside him in front of him in space. And you can actually see it's a virtual image because you can see right through the starship captain and see the wall behind him. In the the sixth now, Star Wars movie, all the people are coming together for a conference, and instead of showing PowerPoint, they're loading their augmented reality 3D model of the new Death Star, and they're planning out how to destroy the Death Star. So when I saw these things as a young lad, I was immediately inspired and thought, boy, I'd really love to be able to do that. But it turns out it's really technically difficult to do that, especially if you don't have the budget of Lucas film. But in order to do this, there are 2 important key problems you need to solve. You need to know where you're looking, so we need to know exactly where the person is and where they're looking, so we can make a virtual image that appears to be stuck in the real world. And secondly, once we've got the 3D model of the Death Star appearing in front of us, we need to know how to interact with this content. When I was in university having this dream of trying to build systems like this, I met this fellow here. And this is a man called Hirokazu Kato, and he's a whole lot smarter than I am, and he certainly is very, very smart when it comes to computer graphics. So, given that we wanted to solve these 2 problems, about 10 years ago, him and I worked together to develop a piece of software called AR Toolkit. AR Toolkit is a computer vision library that takes black square markers, like this one here that has hero on it, and it can find out the position of a real camera relative to this marker. It's very simple. You take the live video input into your computer, it turns that input into a black and white image, just black or white, and then in that image it tries to find, the image processing tries to find the squares. Once you find a square, you can find the 4 corners of the square, and if you know those 4 corners lie on a flat plane, then you can do some pretty simple mathematics and figure out where the real camera is relative to the piece of paper. So now you know that, you basically know where the person's viewing the paper from. Then the second step is to take your virtual gerbil here and position the virtual camera viewpoint at exactly the same spot as the real camera. So because the virtual camera and the real camera are now aligned, you can combine the graphics with the video together, and hey presto, your gerbil appears to be stuck on this little black square. Now, of course, you don't want gerbils on all of your squares, so the other step is that in the middle of the square there's a unique pattern, and you do some pattern identification to say that, this is the Japanese kanji pattern, this is the hero pattern, and so forth. So we developed mostly him developed that piece of software which solved these 2 difficult problems. Where is the person looking, and how can you interact? And when we did that, I then went and solved the Star Wars problems. So the first example from Star Wars was Darth Vader calling his starship captain and making the person appear in front of him as a 3D hologram. So about 8 years ago, we took that software and we had the idea, wouldn't it be neat when you call your friends, if you put the business card down, you'd see your friend appearing out on top of a business card, and you could build your own little spatial conferencing system together and have your friends around you in space. And so we did that. This is a video of a guy making Lego bricks. And with Lego, there's a problem. So you've got the Lego book, and some people are spatially challenged. And when they look at the picture in the Lego book, they can't figure out how the bricks go together because it's a 2D picture of a 3D scene. So in our version of the Lego book, when you look at these black square markers here, you can see an animated 3D image of the Lego bricks coming together on the marker. And if he wants to, he can pick it up and he can look at it from any angle and he can understand how the objects come together. But this guy is not very Lego capable, so he's going to call the Lego helpline for some help. So here's the Lego helpline. So he's got a business card, he turns the business card over, there's another one of these little markers, and hey presto, the nice woman from the Lego helpline pops up and starts talking to him in Japanese and giving him a hand with his problem. What we also do is we take the live video feed from his camera and we feed it back to her so she can see through his eyes and help him solve his Lego problem. So that was the first Star Wars problem solved, getting the remote person to appear in the same space as you. And then, of course, the second one was that you and all your buddies stand around the table and you can see virtual objects on the table in your midst. So about in 1999, we developed this application for Siggraph. And it was a simple card game application. You stand around the table, you turn cards over, and on the cards you would see virtual characters. And the goal was to match the characters together. A very old, grainy video, but you can see there's a little alien appearing on this little card here. And there he is. And so that the task is to work with your friend to find the card that belongs with the alien. So the key is that you can see your friend across the table as well. So it's just like having a face-to-face meeting, but now the virtual content appears on the table between you. So here's a broken heart, and obviously the broken heart and the alien doesn't go together, so when she puts those together, nothing's going to happen. Now, when you look at this virtual content, she's seeing the alien from the front and can see in his eyes, and he's seeing it from the back, so you can see the backside of the alien. So it's just like the Star Wars example, where you can get everybody around the table, and if I wanted to, I could replace the alien with a Death Star, and we could reenact that scene. Okay, there's a UFO, and you can bet the alien and the UFO go together. So when you put the two together, hey presto, you get a little animation of an alien flying around the Earth, zapping it with, this is about the same year that Independence Day came out, so it was kind of a take on that. But we can use the same technology to also do some interesting interaction techniques. And one of the areas we've been working on in the last 8 or 9 years is this notion of tangible augmented reality. So the idea is you take tangible user interface input techniques and you blend them with augmented reality display techniques. And the basic one-liner is you use physical objects to interact with real AR content. So as an example of how you do that, we envisioned a IKEA catalogue of the future. So the idea is in the future, IKEA sends you the catalogue, you open the catalogue, you can see virtual furniture popping out of the catalogue, and then you can arrange the furniture as you like in your own little house. So this shows it working here. You can't see what he's seeing because it's all on the headset display, but it's obvious he's taking things from the book and putting it on the piece of paper. So let's look inside and see what he's doing. Okay, so here's the book, and on the pages of the book there's all this furniture. On the big piece of paper is an empty room, and then you can take the paddle, and when you put the paddle over the piece of furniture, it executes a copy function, copies the furniture, and you tilt it. It has some physics, so you can slide the desk off, then you can push the desk around a little bit to arrange it how you like it, and okay, there's the desk in the corner of your room. So it's quite a complex task to arrange a 3D scene, and you can see he's doing it with just a paddle made of cardboard with no mouse or keyboard or anything like that. So it shows the benefit of having this real tangible physical input. Doesn't like that one, so he just throws it away. And he takes the second rug and puts it down and decides the second rug doesn't like that one either, it clashes with the couch. So you can hit it and it goes away. So the idea is that by using physical objects to interact with AR content, again with the AR Toolkit markers on the objects, you can build very, very intuitive interfaces. Now, of course, what you want to do when you build your house is you want to go inside it and you want to experience it at life size. So the next thing we did is we developed something called the Magic Book. And the idea of the Magic Book was very simple, is you could take a real book you can normally read, and then with an augmented reality system, you could see virtual content popping out of the page of the book. And then when you find a scene you want, of course, you can fly inside the scene and become part of the content. So you can transition from the real world through to an immersive virtual reality. So this is also a collaborative interface. So of course, people can read books together, and frequently do read them together. So you'll see my friend Bruce and I reading this book together. And there we go. It's Japanese, so that's why we're opening it from the back to the front and so forth. And then what we can do is we can take a augmented reality display and look through the handset of the display and see augmented reality content. And just like with the UFO and the alien, we can both see it from our own perspective, and it appears popping out of the page there. So here we are looking through our little handheld displays, and looking a little goofy, but anyway. Every second page is a scene that you can fly into. And so here's the scene, and you click a button, you fly inside the page, and now you become immersed inside the virtual reality experience of the page. Now, when you turn your body in the real world, you can turn around and you can see the immersive virtual reality scene in the real world, and you can push a button on the handheld display and you can fly in the direction that you're looking. Now, this is a collaborative interface, so when I fly into the scene, my buddy who's looking at the augmented reality scene on the book, he can see me as a little person in the scene now. Right, so here's me in the virtual world. And this is, as I move through the world, my body moves around. And then in order to keep the metaphor consistent, when I'm in the immersive virtual world, I should be able to look up into the sky and see my friend looking down at me as this big kind of godlike person. And I can look up and see my friend who looks just like me because we are on a budget. And as he moves in the real world, his head moves around as well. And of course, he can also come in and be in the immersive VR world with me too and fly in, and we can play together. So we were having so much fun with that we released the software and made it open source. It turns out a lot of people like that, and since 2004 we've had 200,000 downloads of this piece of software. It's the second most popular computer vision application on SourceForge. We're getting about 8,000 to 10,000 downloads a month right now. But it turns out most people don't want to look like this to have an AR experience. So if you want to bring AR to the masses, you've got to look at other things as well. And most recently we've taken that same software and we've ported it over to the mobile phone. It turns out to have an AR experience, you just need a camera, a processor and a display. And almost all mobile phones like this one have a camera, a processor and a display on it. So in the last couple of years ago we took that software, ported it to the mobile phone, and here you can see on a normal commodity mobile phone a little 3D model appearing on your phone. Now that's significant because this year there'll be 1 billion mobile phones sold with cameras, processors and displays in them. Oh, and this is a little tennis game we developed, the world's first collaborative AR game on a mobile phone. So you sit across a table with a piece of paper between you, and you can see a virtual tennis court, and you can play tennis together. And of course, because it's a phone, when you hit the ball, you can hear the sound of a ball being hit, and also the phone vibrates as well, so you get some tactile feedback. Now, the nice thing about putting things into the public domain is that other people take your software and do really cool stuff with it. So it turned out that there's a guy in Japan called Sakusha. I don't think that's his real name, but anyway. And Sakusha took the AR Toolkit software and he ported it to Flash. And that's really amazing because now when you've got it ported to Flash, it means you can develop AR experiences that you can experience with the web by millions of people. So this is the live demo. So here's Build AR. It's completely free. You can download it and use it for yourself. And what Build AR lets you do is make your own little AR scene. So here's my little marker. Right now I've got a blue cube on my hero name tag, and I can click on it and do some things like move it around and that type of stuff. I can do this one, which is a scale to make it bigger or smaller. I'll scale along this way. Thinner. Okay. So that's one object. You can also add more objects. So here's a second marker. This one has nothing on it yet. So what we can do is we can say we want to make it active. So we click this button here. We click this here. Go to here. Yeah, okay, now we've got a little cube, but that's kind of boring. So because I'm from New Zealand, I want to put a sheep on here. So we'll click on this and we can go to, this might be dangerous, let's see what happens. Oh, there we go. And so there's a little sheep running around. He's moving very fast, isn't he? So let me make him a bit bigger. Okay, oops, now he's gone. Oh, he became very small. There we go. There you go. Good. And on the other one, here, also because I'm from New Zealand, we can put a kiwi on there. Okay, there's a kiwi bird. And then we can hit this button here and it goes full screen. So in just a few minutes, you've made your own little AR demo. And you can save that out and then reload it again. So basically, obviously you can't tile the world with little black and white squares. So a lot of people are doing some very interesting research on natural feature tracking where they can take normal pictures and track off, and that's what you're seeing in the research community now, and we're doing some work on that in New Zealand as well. The other what's next thing is to take that technology and deploy it on a massive scale. So what you want to be able to do is walk around, well, this is Helsinki, but walk around town and see all these annotations appearing over the real world. So your friend Jusmo might have gone to this burger place and he's left this tag here saying burgers and wrappers are awful, avoided at all costs. So we're doing research in that area, basically taking Web 2.0 technology and blending it with handheld devices and with feeds from Flickr and other subscriber services to use your mobile phone as a portal into massive amounts of content. So just to conclude, developing augmented reality for the masses and letting anybody build an AR experience is all about delivering to existing platforms, so delivering to the web or to mobile phones. It's about building easy-to-use tools, and it's about providing a magical user experience. However, there's an alternative motive for me giving this talk, and that's to reflect on the process itself. And so the lessons that I learned by doing this, first of all, is follow your passions. You know, I saw Star Trek or Star Wars when I was a 8-year-old, and that stuck with me, and through my life I wanted to recreate the Star Wars experience. Then you need to find playmates that are smarter than you. And I found Hirokato, and he was really smarter than me, and he helped build the software. Solve important problems. We solved the tracking problem, the interaction problem. Share your toys. So we built the software library, we shared it to other people, and we've now got more than 200,000 people using that software. Build tools that people can use, like the Build AR. And finally, most importantly, is make magic and show some really amazing demonstrations that can inspire people to do better than what you've done yourself. So I know now that you all want to do this for yourself, so go to this website tonight, download Build AR and build your own little sheep and kiwis. Or if you're a bit more ambitious, you can try and use AR Toolkit and build some nice AR applications as well. So thank you very much for your time.